Hello, everyone. In this lesson, we will start learning about the while statement. In everyday life, we often find ourselves repeating the same action multiple times. For example, during the fourth round of eye exercises, we repeat the action of massaging the eye sockets, or when playing table tennis, we repeat the action of swinging the paddle. In Java, we have a special type of statement called a loop statement, which allows us to repeat a block of code. Loop statements include the while loop, do-while loop, and for loop. Additionally, Java provides jump statements to control the flow of the loop. Next, we will provide a detailed explanation of the while loop statement. The while loop statement, similar to the previously discussed conditional statements, relies on a condition to determine whether to execute the statements inside the curly braces. However, the while loop statement repeatedly evaluates the condition. As long as the condition is true, the statements inside the curly braces will be executed. The loop continues until the condition becomes false, and the while loop terminates. In the given syntax structure, the statements inside the curly braces are referred to as the loop body. The execution of the loop body depends on the condition. When the condition is true, the loop body is executed. After the loop body finishes executing, the program evaluates the condition again. If the condition is still true, the loop body is executed again. This process continues until the condition becomes false, at which point the entire loop process terminates. The execution flow of the while loop is illustrated on the screen. Next, we will demonstrate the usage of the while loop by printing the natural numbers from 1 to 4. The specific code is shown on the screen. In the third line of the code, a variable x is defined with an initial value of 1. Under the condition x is less than equals 4, the loop body will be repeatedly executed. It will print the value of x and increment x. The program's execution result is shown on the screen, where x values are printed as 1, r, 3, 4 respectively. It is important to note that the code in line 6 of the file changes the value of variable x in each iteration, ultimately modifying the loop condition. Without this line of code, x value would remain 1, and the entire loop would enter an infinite loop state, never ending. In case 2, a nested logic of while loop and if-else statements is used. The case initializes a flag variable I with a value of 0. It first checks if I is less than 11. If it passes the condition, the flag variable is incremented by 1. Then, it checks if the current value is even. If it is, it prints the asterisk. Otherwise, it checks if the value is 5. If it is not, it prints 2 pound symbols. Otherwise, it prints a series of dollar signs. After each logic is executed, it checks again if I is less than 11. If it is, the loop continues. When I is equal to 10, the program still enters the loop body, and at this point, I is equal to 11. The program continues with the odd or even check. That is, if it is an odd number, check if it is 5. When the loop body is finished, and it goes to the next iteration, the check if I is less than 11 becomes false, and the loop exits, ending the program. The program's execution result is shown on the screen. When using loops, if a flag variable is used to determine whether to execute the loop logic, it is crucial to ensure that the flag variable's value changes as expected. If the increment operation for the flag variable is removed, it will result in the program running indefinitely, which can lead to resource consumption, or even an infinite loop. Please use the while loop that we have learned to complete the exercise on the screen. Write a program to calculate the factorial of the positive number 5. Based on our analysis, the factorial of a positive integer is the product of all positive integers less than or equal to that number. For example, the factorial of 5 is calculated as 1 asterisk, 2 asterisk, 3 asterisk, 4 asterisk, 5, resulting in a product of 120. Therefore, 120 is the factorial of 5. Now, let's write the code for this exercise. We will use a while loop to calculate the factorial of 5. First, we define a variable I with an initial value of 1. We also define a variable sum with an initial value of 1. Then, we construct a while loop with the condition I is less than equals 5. When this condition is true, we enter the loop body. Inside the loop body, we have two statements. We increment the value of I by 1 in each iteration. Finally, we need to perform the output. And we can observe that in this code, sum we first define variables si and sum with initial values of 1. Then, under the condition I is less than equals 5, the loop body will be repeatedly executed. Inside the loop, the value of sum is multiplied by the value of I. Sum and the product is assigned back to sum. Finally, the variable I is incremented by 1. Once the loop ends, we print the value of sum. Running the program, we can see that the factorial of 5 is indeed 120. That concludes our lesson on the while loop. Goodbye, everyone. Write down the result of the program.